Hi, this is ET370, Lecture 9, Part B, and here we will cover just the three logic operators, inverter and NAND. It's kind of a review of what we just went over, but kind of formalized and with the context of looking at an Arduino or a little microcontroller, how would you implement it digitally? Here's just a summary of all of them that we talked about last time: inverter, and, NAND, or, NOR, exclusive or. And just a reminder, the nice thing is if you know how to make a NAND or a NOR, you can actually create all of these logic operators, which is really cool, okay? And from last lecture, we talked about how the inverter and NAND can be created with the CMOS, okay, which is just a combination of PMOS and NMOS. But let's look at these three. And so again, the inverter, we also call this a NOT, okay? And we'll start with a buffer. And a buffer is very simple. It just means if you have an input, the output just follows that, right? And the symbol is just a triangle, right? It just maintains the integrity, okay? So input, output, they're the same. I mean, I'm gonna have here A and A are the signals here. Now, inverter or the output is not the input. The symbol has the little bubble like we talked about last time. And what we do is we add a little bar on the algebra here to show that this is also inverted. The truth table, if I'm going to write the formal truth table, if you have the input A, and these are the two, what do you call it, binary like input 0, 1, then the output is just 1, 0, just completely opposite. Super simple, right? Now, let's say we wanted to implement it in Arduino or a microcontroller, right? And so what you'll use is the exclamation key if you're operating on a Boolean variable. Remember, Boolean is like a 1 or 0, all right? And so, for example, if you have the command or the line of code exclamation point 1, that's going to return actually the value 0. And so we can ask ourselves the question, let's say you had a statement, if this is in your if statement, will the stuff in the curly brackets execute? So what is this asking? If we have a not here, right? This is the inverter. And then we're asking the question, does 3 equal to 4, right? And this is double equal. So this is, what do you call it? Asking the question, not an assignment. So does 3 equal to 4? No. Okay, so that's a 0, but then you're inverting the 0. So you're actually getting 1. So then, yes, you are going to be able to execute this, right? So 3 doesn't equal 4, 0, not 0 returns 1, yes. Okay, good. Now, we might actually have a variable that has multiple binary numbers in it, right? So you might have a variable like this. And so I put this B here to signify that's a binary number. And you might have 1001, 1011. And you might want to operate on all of them, right? Not just one at a time. This is where this command is good for one at a time. And you might want to use this thing called the tilde, right? So we call this a bitwise operator versus a Boolean operator. It's doing the exact same thing, except this can handle multiple values within one variable. This one is only handling a variable with only one binary value, 0, 1. Okay, so it's the same thing, right? Now you just go bit by bit, bitwise, and say, if I want to do a not or an inversion on this variable, I can do this, which means I get everywhere I see a 1 becomes a 0, and I just basically invert the bits. Very simple. We actually call this, we have a term for this. So this is called one's complement, all right? Which means that actually we're going to see two's complement later on. And two's complement relates to the sign SIGN of a number, okay? All right. Okay, we've dealt with an and before, and this is a little review. We had the bullet symbol, and now notice we have a multiplication, A times B. And I think that makes sense because if you look at this, 0 times 0 is 0, 0 times 1 is 0, 1 times 0 is 0, and 1 times 1 is 1, right? So this is your output, A times B. All right. Now, how would you implement it in Arduino? We have actually seen this, right? We use the double ampersand, right? But this is, again, if you're only dealing with a Boolean number. So let's look at this example. Will this execute? Okay, so what is this asking? So on the left side here, what do we have? Is 7 greater than 4? And on the right side here, we have, does 3 equal 4? And then we invert that answer. And then we're comparing the and of both, right? And so is 7 greater than 4? Yes. So this is a 1 over here. Okay. And what about this? Well, we did this before. So this is a 0 and not of 0 is 1. So we have 1 and 1. The answer is yes, this will execute 1 and 1, right? Okay. What about bitwise? right? Remember we talked about if we have a variable with multiple binary numbers in it, we just use a single ampersand. And so if you have a variable like this port D equals B11010110, and by the way, just an aside, this port D is actually a special, I guess, variable. It's a register for the Arduino pin 0 and 1. It's kind of like you're able to turn it on and off, right? Without using digital write. It's like in one go, you can just turn things on. It's pretty cool. Anyways, what if I do this? Port D, which is originally signed as this, and this binary set of data, right? So I'm ANDing this and this bitwise. If I want to overwrite port D, what is the new value of port D? Well, I can literally bitwise these together. So 0 and 1, well, that's going to be a 0. That's going to be a 1, right? So what do we get? 0 and 1. And then look at these. If I AND anything with 0, what happens? I kill it. Right? Anything ANDed with zeros gets killed, right? And so notice ANDing something with zeros clears it out, and ANDing something with ones makes it unchanged, right? Notice these, if I AND these two with ones, nothing happened to it, right? That's a little trick there, and we'll see that later in the last lecture. Okay. So then let's look at the NAND. Okay, so the NAND, we talked about it before in the first part of this lecture series. We have a little bubble here. We have the multiplication of an AND with a little bar. So this is the NOT or the inverter, right? We have the truth table. We've done this already before. It's basically the same as the AND, except you just invert the outputs. And let's remind yourselves, good, zeros and ones and zeros, excellent. And then the Boolean, what is the Boolean operator and the bitwise? Well, all you got to do is take the AND and put a little NOT on it, or you take the AND, the bitwise, and put a tilde. Simple, simple. Okay, well, that concludes this part of this lecture, and we'll see in the next one where we'll go over OR, NOR, and exclusive OR. All right.